Students, in this video we will discuss the topic relational constraints. So what are constraints? Constraints are various restrictions on data. So there are four types of relational constraints: domain constraint, entity integrity constraint, not null constraint, and referential integrity constraint. So first is domain constraint. Now, domain constraint is a constraint which limits the values on an attribute to some prescribed set of values. Means domain constraint limit the values of an attribute. For example, if suppose we have assigned an attribute to be a numeric type, then we can't give character values to that attribute. So we have limit the values on an attribute. The data type associated with domains are integer, character, string, date, etc. So every attribute is associated with the domain and can have the value from the corresponding domain only. For example, let us consider the table in which we have attributes roll number, name and class. Now suppose we have assigned roll number as numeric data type, name and class as varchar. But as you can see there in the third tuple, we have a value in roll number Neha. Now this is a character value which is assigned to a numeric attribute. So this is not allowed because the domain of roll number is only numeric type. So the domain constraint are tested every time a new data is added to the database. Now second is entity integrity constraint, which means no attribute of a primary key can have a null value. As you all know that primary key has two features, not null and unique. So this is obvious कि if we have assigned any attribute as a primary key, that attribute cannot have a null value. So this is because primary key values are used to identify the individual tuples. So this is known as entity integrity constraint. Third constraint is not null constraint. Now other attributes of the relation are also not allowed null values even though they are not members of the primary key. As we have already discussed in the previous slide that primary key cannot have null values. Similarly, we can apply not null constraint to other attributes also. Suppose we have assigned not null constraint to name attribute. So name attribute cannot have null values. Last constraint is referential integrity constraint. This is very important. Now this is used to maintain consistency among tuples of two relations. This constraint is used when the two relations are connected to each other through a primary key foreign key relationship. Now it states that if a foreign key in relation R1 refers to the primary key of relation R2, then every value of the foreign key in relation R1 must be available in relation R2. Now I will explain this definition with an example. Suppose we have an account table in which we have the attributes account number, name, balance and district. We have another table branch in which we have district and state. Now district is a primary key in this relation, and in account relation district is acting as a foreign key. So differential integrity constraint says that every value of prime foreign key must be present in the primary key table. So as you can see that district Sonipat is not allowed in account relation because it is not available in branch relation. As you can see, district is primary key in branch relationship. You don't find any record of district Sonipat in this table where it is a primary key. But you have a record of Sonipat last row in account table. Now, uh, this is not possible because Sonipat district is not there in branch table where this district attribute is acting as a primary key. So this is referential integrity constraint. Again, I am repeating the definition. If a foreign key in relation R1 refers to the primary key of relation R2, then every value of the foreign key in relation R1 must be available in relation R2. So I hope you have understood the topic. Thank you.